Welcome back. Today we're going to talk about comparing linear functions. Okay, so oftentimes you're given a word problem and you're asked to sort of compare, a lot of times it's like price structures. So we're going to go over a situation where there's two different plumbing businesses. Joe's and Mark's Plumbing have two different ways of charging their customers. The function defined by J of T is equal to 40T represents the total amount of dollars that Joe's Plumbing charges for T hours. So he charges just $40 an hour, it looks like. And Mark's Plumbing charges a $40 per hour plus a $25 trip fee. Okay, so if you were to fill out these tables, basically Joe, it's just going to be $40 for every hour. So it's going to be 40 times 1, which is 40. Let's see. So this is 40, and so 140 will be here. This is 80, and then 120 right here. So it's going to be 280 and 120 right here. Okay. For this next one, for Mark's, if I were to fill it out, it would be 40 times 1 plus 25. So it would be 40 plus 25, which is 65. So this would be 1 comma 65. So you can see at 1 hour, it costs more for Mark's Plumbing service. At 2 hours, it's going to be 80 plus that 25, which is going to be 105. So I know it's getting a little messy on this side here, but let's see, 2 and 105. At 3 hours, it's going to be 120 plus this plus the 25, so it's going to be 120 plus 25 is going to be 140. So it's going to be 145. Okay. Which domain and range values for the function J of T and M of T are reasonable for this context? Explain. Well, first of all, let's graph it. So this is J of T. It's 140. It would be 280 and 120. So here I want to go, actually starts at 0, so I can just go ahead and graph these. Right here, y is equal to 40x. Here it's going to start already at 25, so the y-intercept is going to be 25, like right here. And the slope is going to be 40, so it's up 40. So if they each go up 20, so I'll go up 1, 20, 40, and over 1. Do the same thing, so it's 20, 40 over 1, like that. 20, 40 over 1. So here is Mark's Plumbing business. So y is equal to, 40x plus 20. 40x plus 25 should be on that. It's a little difficult for me to write it, but you should write it in your notes. That's 40x plus 25, and that's M of T. And I guess I should put this as J of T. J of T is equal to 40x. Okay. Okay, when we talk about the domain right here, we want to think about what sort of value you want to put in for the hours here. And actually Mark and Joe are going to have about the same domain. So for both Mark and Joe, a lot of times people who work on things have a restriction where you can't have partial hours. And let's assume that Mark and Joe are in the same category, because they don't want to be charged for, like, I don't know, a quarter of an hour, half an hour. They usually round up to the nearest hour. So we're only dealing with integers. And furthermore, since there can't be negative hours, we're really just dealing with the integers that are positive. Now the positive integers are just what we call whole numbers, because we could also include the value of 0. So their domain are just whole numbers. Let's say there was a further restriction on their service where they won't work more than like 10 hours, for instance. Well, then we could say all whole numbers between 0 and 10. We could say that, or all whole numbers less than or equal to 10, since whole numbers start at 0 anyways. Okay, so that's a way of determining domain if there's restrictions here. Okay, doesn't make sense to have negatives, so we're going to throw those out. Doesn't make sense to have partial hours, so we're going to throw those out. What are we left with? We're left with whole numbers. Okay, so one way of comparing, so just remembering this is a lesson on comparing functions, we can look at the coordinates here and say, well, for the most part, for always actually, Joe's cost more than Mark's because Mark has this initial fee of $25, whereas but they both have the same hourly rate. So when we ask for a comparison, and in a lot like when you're in English class, we want you to look at the rate and the initial value and use those two things to create comparisons, like to judge one cost structure or one function against the other function. Okay, when you're comparing functions, so sometimes you might be asked to compare functions that are in two different forms. So here we're given a function f of x and g of x, and the function f of x is defined by the coordinates in the table. And it looks like it's only defined by the domain of each function is a set of all real numbers between 4 and 7, including 4 and 7. So here are some values of f of x. It looks like what f of x does is it doubles x. And they say that g of x is defined by the rule g of x is equal to 2x plus 3. Okay, well they want you to find the initial values and the range of each function. So let's find the initial values and compare them and compare the ranges of each function. Well, since g of x is this rule, right? So g of x is going to be 2x plus 3. And then f of x is going to be 2x. So it's really just 2x plus 0. It looks like g of x has an initial value of 3 more than f of x. Now, if both g of x and f of x are defined for all real numbers between 4 and 7, then what's going to happen with the range is your g of x is going to have a range. All it does is it takes f of x and it takes 2x and adds 3 to it. So this is going to be 11, 13, 15, and 17. Okay, so given this domain of all real numbers between 4 and 7, f of x is going to have a range of all the values for f of x are going to be between 8 and 14. So we can write it this way, that f of x is greater than or equal to 8 and less than or equal to 14. So the values of f of x are between these two, whereas g of x ranges between the values of 11 and 17. Okay, so it's always 3 more. Its endpoint is always it's both of its endpoints are always 3 more than f of x's endpoints because it takes f of x and essentially just adds 3 to it. Okay, so that's how you can compare them when they're in two different forms. Given this word problem, let's see. This is comparing linear functions given a description and a graph. So a rainstorm in Atlanta lasts for 2.5 hours, during which time it rained at a steady rate of ½ an inch per hour. The function a of t represents the amount of rain that fell in t hours. The graph on the right shows the amount of rainstorm that fell during a rainstorm in Knoxville. So in two different areas, Atlanta and Knoxville. K of t, so it looks like K for Knoxville, t, shows the amount in inches as a function of time in hours. Okay, so this right here, so this is a verbal description of a function. So let's just write these functions out. A of t is equal to, it's ½ an inch per every hour t, and it lasts for 2.5 hours. So your domain are going to be all hours between 0 and 2.5. So my domain is the time between 0 and 2.5. And here, my domain for the Knoxville rainstorm is actually going to be between 0 and 2. Notice that this graph right here is just defined between the hours of 0 and 2 hours. And its function is going to be, let's see if we can find its y-intercept is 0. So what's its slope? This goes up 5 inches in 2 hours. So the slope is the rise is going to be 5 over 2 inches per hour. So 2.5, or that's another way of saying it, is 2.5 inches per hour. So your K of t is just going to be about 2.5 inches per hour, and they both have a y-intercept of 0. So you have A of t and K of t right here, which is ½ an inch per hour. Okay, and the domain of the first one is all time between 0 and 2.5 hours, whereas the domain for the second one is going to be between 0 and 2 hours. Okay, so compare the y-intercepts. They actually both have a y-intercept of 0. Okay, because it didn't say that there was any rainfall initially in the Atlanta rainstorm, and the Knoxville storm shows that the y-intercept it goes right through the origin. Okay, so they both are 0. Compare the slopes. Okay, so the slope of the Knoxville rainstorm is actually raining a lot harder in Knoxville. It's 2.5 inches per hour because the rainstorm only lasted 2 hours and it rained 5 inches here. So here the slope is actually going to be, what is that? How many halves are there in 2.5? There are 5 halves in 2.5. So the Knoxville rainstorm rained 5 times harder than the Atlanta rainstorm, because Atlanta only rained 0.5 inch per hour, whereas Knoxville rained 2.5 inches per every hour. Okay, so that's another way of comparing them. You can compare their initial values, you can compare their slopes, you can compare their domain and range like we've seen before. Depending on what the question asks you, you're going to be, remember the way that you compare something though is that you don't just state the value of one and the value of the other. You say things like greater than, it's equal to, it's less than, it rained harder. You can use terms like it rained 5 times harder in Knoxville than Atlanta. You can use the idea of comparison that you write in essays for English in terms of comparing functions in mathematics. And that is the end of the lesson for today. All we did was we looked at functions that were given in different forms, and we went back to the equations of the functions and compared things like slope and y-intercept and domain and range.